Hello dear students, good afternoon. I am your tutor Dr. Ram Rashid in front of you. The topic today we have discussed resistances in series. The resistances in a circuit, in everyday circuit, the resistances can be connected in two ways. Either the resistance can be connected in series or it can be connected in parallel. The first thing we will discuss here is the resistance in series. How the resistances are connected in series. For example, if we have a circuit here, so it is one resistance, okay dear. So it is another resistance, then we have another resistance, for example, so that is another resistance, okay dear. So this is the resistances are connected in series and there is a battery connected plus and minus, okay. So this is the resistances are connected end to end, that means resistances are connected end to end, okay. So the resistances are connected end to end. That means when one end of the resistance is connected to the other end of the resistance, that's called resistance in series. So that's called when the resistances are when the RSISTA and CES when the resistances are connected when the resistances are connected from end to end, when the resistances are connected from end to end, when the resistances are connected from end to end, then when the resistances are connected, so they are saying end to end such that same current flows, such that same current flows, such that same current flows, such that same current flows through the circuit, such that same current flows through the circuit, such that same current flows, such that same current flows through the circuit, okay, CIRCU, such that same current flows through the circuit, then so whenever the resistances are connected end to end, we can say that the resistances are connected in series, okay. So such that same current flows, through each of them, then the resistances are said to be said to be in series. Then the resistances are said to be in series. Okay. Then the resistances are said to be series. So whenever the resistances in a circuit are connected end to end, what is meant by end to end? End to end means the end of the end of one resistance. If this is first resistance, if this is second resistance, if this is third resistance, so it means the end of one resistance is connected to the to the beginning of the first resistance and second resistance, and the end point of the second resistance is connected to the starting point of the third resistance. That is what is called end-to-end resistance. Such that so whenever the resistances are connected in series through all the resistances, if we have n type of resistances, if we have one resistance, second resistance, three resistances, for example, if we have 100 resistances, so that resistances in series implies that through all the 100 resistances the current flow is same. So then we can see the resistances are connected in series. Now if the current flow is same, for example, if the by the potential drop across them is so and current, let us suppose that the potential difference, since the current through all the resistances is same, so let us assume that the potential drop across each resistance is V1. Let us suppose that potential difference, let us suppose that potential difference through each resistance. Let us suppose that potential difference through each resistance. Let us suppose that potential difference through each resistance. Let us suppose that potential difference through each resistance. Let us suppose that potential difference through each resistance is V1. Is through each resistance is V1, V2, and V3. So let us suppose the potential across the resistance is V1, okay, is V1, and let us suppose the potential difference across the resistance R2 is V2, okay, and here it is V3, here it is V3, okay. So let us suppose the potential difference across resistance R1, R2, and R3 are V1, V2, V3. Now let us apply the Ohm's law. So according to Ohm's law, what Ohm's law क्या बोलता है कि what is meant, what is the definition, what is the statement of Ohm's law? The statement of Ohm's law is that according to Ohm's law, So according to Ohm's law, okay, according to Ohm's law, according to Ohm's law, V is equal to IR. According to Ohm's law, V is equal to IR. Okay. So this is the Ohm's law. Now, for the resistance R1, potential across the resistance R1, the potential across the resistance R1 is V1. Therefore, I will write here. Therefore, V1 is equal to IR1. V1 is equal to IR. Why I wrote I? Because the resistance, when the resistances are same, when the resistances are connected in series, when the resistances are connected in series, I mean from end to end, then the current through each resistance is same. So V1 is equal to R1, V2 is equal to IR2, and V3 is equal to IR3. Okay, V3 is equal to IR3. So therefore the total potential will be V1 plus V2 plus V3, which is equal to IR1 plus IR2 plus IR3. Okay, IR3. So it means I into R1 plus R2 plus R3, I1 plus R1 plus R3. So that is the total potential. Vt is equal to IRS. So it means V is equal to Vt IR1 plus R2 also R3, or we can say so that or we can say therefore Vs is equal to I into Rs. What is Rs? Vs is the potential in the series, potential of the circuit when the connectors are connected in the series, and Rs is the total resistance of the system when the resistances are connected in series. So this is Vs equal to IRS. But so here we found therefore when the resistances are connected in series, that means from end to end, then the total resistance, therefore the total resistance series is given by R1 plus R2 plus R3. Okay, R1 plus R2 plus R3. So this is how to calculate the total resistance in the series. Okay, so it means if we have n resistances, so let us erase here. It means if we have n resistances, it is R1, R2, R3. Okay, so therefore if there are n resistances, if there are n resistances, RESITN, if there are n resistances, then NRS is equal to R1 plus R2 plus R3 plus up to dash plus RL. So these n resistances. Okay, so or we can tell here, or we can say here, R equivalent will be, or we can say R equivalent will be, R equivalent is equal to summation of I. So this is how to find the resistance. So that is the way of finding the resistances. The resistance are connected in series. So it means when the resistances are connected in series, the total resistance is given by summation of Ri. So I runs from 1 to n. So this is how to find the total resistance when the resistance are connected in series. Okay, dear. So we can say here therefore we can say when the large number of resistances are connected in series, then their total resistance is equal to the sum of individual resistances. So therefore I will write here. Okay, therefore I will write here when the number of resistances. Therefore I will write here. Therefore hence when the very large. Sorry. Therefore when very large number of resistances, when a number of resistances, when a number of resistances are connected in series connected in series, therefore when a number of resistances are connected in series, then their equivalent resistance is simply equal to the sum of individual resistances. Okay, are connected. Therefore when a number of resistances are connected in series, there the total resistance is equal to the sum of individual resistances. Sum of individual resistances. Sum of individual. So it means when the large number of resistances, when the number of resistances are connected in series, R1, R2, R3, R4 up to Rn, then the total resistance of the system is equal to the sum of individual resistances, which is given by here. So that's how the resistances, how to calculate the resistance in the series. So this was all about the resistance in the series. So after that, we will some features of the resistance in the series, some laws of resistances. So let us move here to laws of resistances in the series. So let's discuss another concept, laws of resistances in the series. 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 First one is when the resistances are series, when the resistances are connected in series, some features are there, right? The first feature is that when the resistances are connected in series, the same current flows through each resistance. For example, there are 100 resistances. The current I1 with the current I will flow through resistance 1. The same current I will flow through resistance R2. So for example, if we have that means same current flows through all resistances. Same current flows through all the resistances. Same current flows through all the resistances. So that means, what is meant by that? It means if a current of 5 ampere is flowing through resistance R1, the same 5 ampere current will flow through second resistance. The same current 5 ampere will flow through third resistance. The same current 5 ampere will flow through fourth resistance. So it means if we have 100 resistances connected in series, then it means all through all the resistances same current will flow. Okay. So second thing is here. Right? Second thing. So total potential drop. Second, total potential drop across the resistances. Total potential drop across the resistances is equal to sum of potential drop. This is equal to sum of potential drop. That is So what I mean to say is that if we have resistance R1, R2 and R3, if they are connected in the series such that the same current flows through the resistances, then if it means the potential drop will be the sum of potential drops across the resistance. It means if the potential drop V1 is across the resistance R1 and potential drop across the second resistance is V2 and the potential drop across third resistance is R3, then the total potential drop is Vs means it means total potential drop is equal to Vs is equal to V1 plus V2 plus V3. So it means this is the total potential drop given in the series connection. When the resistances are connected in series, then the potential drop is given as like that. Okay, dear. So that is the point. But remember, so I hope you will understand. I hope you understood the fact that when the resistances are connected in series, that is end to end. When one resistance is connected to the beginning of the another resistance, and the end of that second resistance is connected to the beginning of the third resistance, then the resistances are said to be connected in series. And whenever the resistances are connected in series, the same current flows through all the resistances. If we have 100 resistances connected in a circuit, that means through first circuit, if ampere current 1 ampere current is flowing, through second resistance same current of 1 ampere will flow, and through third resistance the same current of 1 ampere will flow. Now after that, let's do here. So now then we have third point. Third point is the third point of this resistance guidance is that are directly proportional to the individual resistance. Is that the equivalent resistance is equal to equivalent here equivalent EQUI VALENT equivalent resistance is equal to equivalent resistance. So equivalent resistance is equal to sum of individual resistances is equal to sum of individual resistances. INDVI is equal to sum of individual resistances is equal to sum of individual resistances. That is R equivalent is equal to summation of I is equal to 1 to N R Ri. Okay. So this is the total resistance given in series combination. So that was all for today. When the resistors are connected in the series, see in the circuits we have in the home, so the resistance can be connected in two ways. Either the resistance can be connected in parallel or the resistance can be connected in series. But today we have discussed the resistance in series. What is meant by resistance is connected in series? The resistance is connected in series means when the resistances are connected end to end. End to end means the end point of the second resistance is connected to the beginning point of the second resistance, and the beginning end point of the second resistance is connected to the beginning of the third resistance. So similarly it will go on, and whenever the resistors are connected in series, then the same current flows through all the resistances. For example, if a current of 5 ampere flows through the resistance, the same current will flow through second resistance. Same current of 3 ampere, 5 ampere will flow through the third resistance. But the potential difference, the total potential difference across the resistances is simply equal to the sum of individual resistances. So that's one of the features that the resistances when connected in series. And the total potential drop is given by V1 plus V2 plus V3. What is Vs? Vs is the total potential drop across in the series connection. And what is V1, V2, V3? V1, V2, V3 is the potential drop across first resistance, and V2 is the potential drop across second resistance, and V3 is the potential drop across third resistances. And the equivalent resistance equal to the sum of individual. And the fourth point I will write is that in the series connection of resistors, the total resistance is more than the individual resistance. That the total resistance in the series connections is more than the individual resistance. So I hope that's all for today. Let's meet next evening and let's meet next day. Till then, all the best.